A serverless application is a combination of Lambda functions, event sources, and other resources that work together to perform tasks. It is more than just a Lambda function. It can include other resources like APIs, databases, and event source mappings. The AWS Serverless Application Model, also called as SAM or SAM, is an open source framework that helps us to build serverless applications on the AWS cloud. In this video, let's learn how to build an AWS serverless application using the Serverless Application Template as part of the AWS Toolkit. We will see how to deploy one or more Lambda functions, API gateways, and also Dynamo databases using AWS SAM. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you like the videos on this channel, please make sure to hit the subscribe button. It really helps me to grow this YouTube channel. Without much delay, let's head right into the code and see more about serverless applications in AWS. I have Visual Studio opened up here, so let's create a new project. Scroll down and click Create a New Project and select the AWS Serverless Application Template. So I have already filtered by AWS, C# and Serverless. And also we have installed the AWS Toolkit, as I had shown you in the first video, which introduces us with AWS Lambda. Check that out here in case you missed it. So once we have the toolkit installed, we can choose the template. So in this case, I'll choose the AWS Serverless application for .NET Core. Let's click Next. This prompts us to enter a name. So let's create a name for this. Let's give in my serverless app. Let's choose the location. So I'll leave it in my YouTube code repository. And let's click Create. This prompts to select a blueprint, which is basically a starter code for this particular serverless application. You have many options here, and you can choose one of them that actually fits your project needs. To start demoing this, I will first create one using the empty serverless application blueprint template. So let's click that and make sure to click Finish. This creates the project and opens that up in Visual Studio. The project is created successfully. And similar to the AWS Lambda, we have the function.cs, the AWS Lambda tools.defaults.json file, and also we have the dependencies, which are the Amazon Lambda API Gateway events, Lambda core, and serialization ones. The only one extra in this template is the API Gateway events, because this integrates with API Gateway. Let's see that in a moment. We also have a serverless.template file, which is basically the SAM application template. We will look at this in detail. We can see this has the functions class and it also defines a get method inside that. Before we go any further, let's understand a bit more about the serverless.template file. The AWS Serverless Application Model helps us build serverless applications for AWS. AWS SAM consists of two components. One, the template file, which we just saw, the serverless.template file, and also the AWS SAM command line interface. So this is the CLI that helps us to interact with AWS and deploy this template file. AWS SAM templates are an extension to CloudFormation templates, and it adds a few properties and components, making it easier to deploy or create these templates. So what is CloudFormation? AWS CloudFormation is basically infrastructure as code. It is a service that helps us model and set up services or resources for our application so that we can spend less time managing them and spend more time building the application itself. It makes it easier to create, deploy resources onto the AWS framework. When you're working with AWS CloudFormation, you're working with templates and stacks. Now, a CloudFormation template is a JSON or a YAML formatted file. You can save these as any extension like .json, .yaml, .template, .text, etc. So these templates are the blueprints for creating resources in AWS for your application. So this represents your infrastructure as code or as a file. Now this is an example of a JSON file. You can also define this in YAML as shown here. Now, when you use CloudFormation, you're basically managing related resources as a single unit called stack. So it's like something like a grouping that groups all your resources that is part of your template file. Now you can create, update, delete a collection of resources by basically creating, updating or deleting a stack. We will see how these are represented in AWS in this video. If you look at the AWS template structure, we have different sections inside these template file. Some of them are required and some of them are not. I'll put a link to this document so that you can go through it in detail. But on a high level, you can see there is a set of globals, a description for the template file, some metadata, parameters, mappings, conditions, resources, and outputs. Now, resources is where we define the resources that's required for our application. So some of these, as I mentioned, are optional and some are required. So have a look through this document to understand more about the structure and what goes where. Coming back to our serverless.template file, let's expand this to understand a bit more. So here we have the template format version. It specifies a transform attribute and also a description. Under that we have the resources section, which is basically defining the resources that's part of this application template. It also grabs a few of the output values and gives in an API URL. We will see this once this application gets deployed. If we expand the get, we have a lot of properties defined inside that as well. The type here specifies the type of the resource. So in this case, this is defined as a AWS Serverless function. Now this is a short form representation because of the AWS SAM model, which is built on top of the CloudFormation structure. So it gives additional features and functionalities like this. Now here in the handler, as we had seen before in our Lambda function video, it specifies the assembly name, the namespace, and then the name of the method inside that class. So here note that even though the file is function.cs, the class name is functions, which is why this is using functions. If you go into the function.cs, you can see that the class name is functions. Coming back to the template file, this has the other properties like the runtime, the memory size, etc., and also policies that's assigned to this AWS Lambda function. Coming to the events section, this defines how this Lambda is triggered. In my previous video, I had used the console and manually invoked it. But in this case, this is exposing this function as an API gateway with a base path of just the root. So this is typically a get method on the API gateway and exposing this function. If we go into the function, we can see that this is taking in an API gateway request and the context and returning back some data. All it's doing in this case is returning a hello serverless message. If you want to explore the different properties and the values associated with it for the AWS serverless function type, you can go to the documentation under the Serverless Application Model and choose the type serverless function. So this defines all the properties that can be there and in the YAML format, but the properties remain the same. So you can read about it and what it does in this particular document link. The AWS CloudFormation Designer is a tool that helps us to build this template. I will put the link in the description below. Now if you see here, this defines the various resource types and you can click and add them to build out the template. I will not go into the details of this tool in this video, but I'll cover that as part of a separate video. But if we go back and select this template, we can copy this into the template section. So right on the bottom tab, we can choose template and paste in the template that we copied inside here. Once we refresh, it will start showing that this is a get Lambda function and the associated properties to it. You can also convert this template from JSON into a YAML format. Now if you simply select between these, it automatically converts that into the YAML format. So you could use this tool to do that as well. Switching back to Visual Studio, how is this template file associated with this whole project? So if we go into the AWS Lambda tools defaults.json, which is basically the toolkit's configuration file, you can see that here there is a template specified. The name specified here and that of the file must match. If there is a mismatch, then when we publish, it will throw an error. So let's see how we can publish this. Now normally for an application, I would have a build deploy pipeline set up to automatically publish this into different environments. But since we are exploring and understanding about the serverless model, let's just manually do that. To do it from Visual Studio, if you have the toolkit installed, you can right-click on the project and select the Publish to AWS Lambda option. This prompts up a dialog where we can specify a stack name and also an associated S3 bucket. Let's create a new bucket. So let's say my serverless app -YouTube and click OK. We also need to specify a stack name. So let's use the same my serverless app as the stack name as well. This S3 bucket is used to upload the packaged application and also the template file, and then AWS will start deploying the template file from this S3 bucket. Now that's how CloudFormation works internally. So it doesn't use it from the local, but it uploads it directly to an S3 bucket and uses it from there. So let's click Publish, and this should publish it into the Sydney region for my account. Clicking Publish executes the publish command and creates the artifact that needs to be deployed. Once done, it zips them into an archive file and uploads it to the S3 bucket. After that, we can see the CloudFormation is kicked in and it creates these resources as we have requested. Now, since I have the open CloudFormation stack view after publish, it has automatically opened that in the back. So let's close this to view more details. Now you can see the stack is still creation in progress. So if you refresh this, you can see that it's now completed. And also it lists the list of things and activities that this particular template file has done. If you go into resources, you can find the resources that's associated with this particular template. Let's navigate to the AWS console to see that in there. So switching to my browser, let's go to aws.amazon.com. Let's sign in to the console. Now it's default to Sydney, the region that we deployed to. So let's go into stacks. So searching from here, and let's search for stacks. So navigating to this, we can see the My Serverless app stack that is created. Now these two other stacks, I tried it to test this video. So let's navigate into the My Serverless app, and we can see the details of that stack. If you navigate to resources, you see all the resources that's associated with this stack. Now as you see, the stack is a grouping of the resources that is part of this application. So we have the get Lambda function, we have a get role, and we also have the serverless REST API. So you can see the type of these resources on the right side. Clicking on this takes us to that particular resource. Now we had seen the AWS Lambda function earlier video, and this is typically the same. So we have the handler that's specified here, and it's using the zip uploaded file. It's also specifying the runtime as expected. Now if we navigate back and go to the API Gateway or the Serverless REST API, we can see the Serverless API endpoints for this application. Now since we specified just a base path URL, on the get method, it's just showing that. So if we navigate to the dashboard, we can see the URL of this particular API. If we switch back to Visual Studio, the output would also have given the same URL, which is coming back here in the AWS Serverless URL. So let's click this to navigate to this particular URL. And it returns us back, hello AWS Serverless, which is the message that the AWS Lambda function returns us. Now that we have successfully deployed one Lambda function, let's see how we can add one more to this whole application. So switching back to Visual Studio, let's collapse this. Let's navigate to the functions.cs. Let's copy and paste the same function. I will just update the name. Let's say we call this get again. So let's add again in all of these comments. So also say hello again AWS Serverless. So this is going to create a new function inside of this class. To use this, let's go to the serverless.template file, copy this whole get section again and paste it below that. Since the names have to be different, let's name this get again. And this function handler needs to map to the get again function inside the same class. We can also update the API gateway route. So let's put this as /again. Now let's save this, make sure it builds successfully, and we can do the same to right click and publish this application. So let's go to the Solution Explorer, right click and say publish to AWS Lambda. So this has all the stack names and the associated bucket saved into this Lambda tools defaults.json, so it's automatically populated. Let's click publish. The publish is successful. This update is also complete. Let's switch back to the AWS console and refresh this stack. We can now see there is a get again Lambda function also available here. If you go to the API gateway and refresh the resources, we can see there is a /again endpoint as well. Now if we go to the dashboard and navigate to this URL, it defaults to hello AWS Serverless. And if we navigate to /again endpoint, it gives back the message hello again AWS Serverless. Now these Lambda functions could be any of your API endpoints doing a get, post, update or delete on your application, or any other functions that can be triggered by different mechanisms. Now let's see how we can build out an API like that. So let's navigate back to this project, close all this, and in the Solution Explorer, let's add a new project. So let's click Add and say New Project. Now similar to before, let's create the AWS Serverless application and use the .NET Core option in here and click Next. Let's name this My API Serverless App and click Create. Now in the blueprint, we already have a blueprint that helps us to set up that. So let's use this to make it easy. So let's choose the blog API using DynamoDB as the option and click Finish. So we have the My API Serverless app created. So let's collapse this away, which has the similar files that we saw before. So this has the functions.cs, which has all the function code, and also it has the serverless.template file, which has a lot more going in here. Now we also have the blog.cs class, which is a data transfer object that contains a few properties. If we navigate to the functions.cs class, we can see that it uses the DynamoDB context. Now if you're new to DynamoDB and want to learn more, check out the video linked here or in the description below. Now this instantiates the DB context right inside the function and uses that inside these function methods. Let's collapse this to see the different functions it has. So it has a get blogs asyncs method. It has a single get blog async which gets a blog by an ID, an add blog, and also a remove blog method. Now if we navigate to the serverless.template, we can see the structure similar to before, with the certain sections more in this case. Now earlier we didn't have the parameters section, but this also takes in that. So it asks whether we should create a new table or not, and also the table name, etc. This is also defining a conditions section, which is building out a condition on which the table should be created or not. Now under resources, this defines a get blog, add and remove like we saw. All of these are AWS serverless functions, which means they are Lambda functions. Now the last one, which is a blog table, is an AWS DynamoDB table. So this is creating the Dynamo database table. Inside here, it's using the condition to determine whether to create the table or not. If you want to see more about the properties and what each of these does, you know where to go. So go to the documentation under the AWS DynamoDB table. If we expand each of these get blogs function, we can see this has an associated policies. So this gives the AWS Lambda full access. Now for some reason, it doesn't have an access to DynamoDB. So if we were to deploy this template as is, it is failing. So let's add in the access policies for DynamoDB. Since I had already looked it up, I know this is Amazon DynamoDB full access to provide full access for DynamoDB. But you can also search the documentation and find out the other specific roles if you are interested in that. So let's make sure to give this in all the policies for these functions. So if we go to get blog, make sure to expand this, add in the policy in here. Similarly for add and the remove blog as well. Let's make sure to remove this extra space at the end so that it doesn't fail. With that specified, let's deploy this application to see how this works. So let's navigate to the Solution Explorer, right-click the My API Serverless app and click Publish to AWS Lambda. Now this again asks us for the S3 bucket and the stack name. Let's keep this S3 bucket as the same as we used before. So let's select My Serverless App YouTube, and for the stack name, let's use My API Serverless App and click Next. Since we have defined parameters, this provides an additional dialog to choose in the parameter names. So you can see the blog table name, the read capacity and the write capacity, and also the should create table to be true. You can switch this to false if you wish so. Let's keep it to true because we want the table to be created, and click Publish. Now this follows a similar process. It first executes the publish, it zips up the publish folder, uploads to S3, and then runs the CloudFormation template. So this is successfully done. So let's close this to see the details in here. We can also navigate to the AWS console and go to stacks to see more details. So let's search for stacks and navigate to stacks. Here we have the My API Serverless App stack created now. It's still in progress. So let's navigate to that to see the resources. This has a lot more resources going on in here because it has a few Lambda functions, a DynamoDB table, and API gateways as well. So if you want to sort or search, you can do that using this bar and use this to sort the values that comes back. Now, if you want to go to the API gateway, we can search for API gateway and navigate to that. In this case, we have a delete, get, put, and a get by ID method. So there are different methods on this endpoint in this case, which points to different AWS Lambda functions. Let's navigate back to the stack, refresh this to make sure this is complete, and start using this API endpoint. To see the data actually getting created, let's go to the Dynamo table and open that up in the console. Now here, in this DynamoDB, we have the My API Serverless App blog table already created. This was done by the template file that we just ran. If we navigate to the items section, this is currently empty. So let's start adding an item. In this case, we need to make a put request and give in the blog object. To test this function, we can either pass in the attributes from here or use a tool like Postman. So let's open up Postman, which I have already installed on machine. You can get it for free and the link will be in the description below. So let's click the plus button to create a new request. Now since we know this is a put request, let's switch that to put. Let's navigate back to the console and to the dashboard to get the API URL. So let's click this and copy this URL from the browser. By default, the get all is returning an empty array because we don't have any items inside the DynamoDB. Let's copy this URL, switch back to Postman and use that URL in here. Now we don't need any authorization, so let's choose no auth. Let's switch to body, make sure this is raw, and also select that this is a JSON type. If you go to the functions.cs and expand the add blog, we see that the ID and created datetime is automatically set by the code. So if we navigate into the blog.cs, the only properties we need to set is the name and content. So let's switch back to Postman and specify the name property. Let's say AWS Serverless and the content property. So let's say this is a test blog. Now we can make a post request with this. So let's click send. It successfully returns back an ID of the object that is created, which is exactly what the function does. So if we switch back to functions.cs, we can see this is returning an API gateway response and the body has the blog.id. Now if we navigate to the DynamoDB in the console and refresh this, we can see the item that we just created. The ID of this matches the ID that was sent back. Now we successfully created an item into the DynamoDB table. So if you go back to this URL and refresh this, this starts getting all the blogs in this DynamoDB table. If you want a specific blog item, you can specify the ID that we just copied into here and make a request. Now this is returning the specific blog item and not an array of blogs. Similarly, if we want to delete the item, we can navigate back. Let's create a new tab request, specify that it's a delete request, and copy this full URL to the specific ID and use that in the delete request. Note, in the delete request, we didn't have any parameter specified because here we have the ID that was coming after slash, which is why the route got matched when I specified this ID after the prod endpoint. However, with the delete endpoint, it's not like that. How this is defined? This is defined in the serverless.template file under the events section. If we navigate to the get blog method, we can see the events has the /id parameter specified in here. So this is the route template that gets used. However, with delete, that's not specified. So in that case, we'll need to explicitly pass in as a query parameter. And the function.cs retrieves this id parameter from the query parameters using a specific name. So it's hard-coded this as the id property. So let's pass that into our URL. So switch back to Postman and make this a /prod, give $id is equal to the ID that needs to be deleted. Now this is a delete. So let's click send. It's returned a 200 OK. Let's switch back to the DynamoDB, refresh this and that item no longer exists. So we have successfully deleted it from the DynamoDB table. I hope this helps you to understand more about the AWS Serverless Application Template and how to build serverless applications in the AWS environment. In a later video, we will see how to automate this SAM application template from a DevOps pipeline and not have to manually deploy this every time to different environments. If you like this video, please make sure to hit the like button. If you have any questions or feedback, do let me know in the comment section below. As part of this AWS series, I am building a lot more videos. So if you want to be notified of it in the future, please make sure to hit the subscribe button. Thank you and see you soon.